Hi, everyone. My name is Nathan Harvey. I lead up the DORA program here with Google Cloud, and this is my first shipped. It's, of course, not the first time I've shipped anything, but it is my first shipped conference, and I'm so excited to be here together with Steve. Hey, Steve.
Hey, how's it going? Hi everyone, I'm Steve. I am a DORA community guide, and I have the
Yes.
T-shirt to prove it. And I also work at Octopus, doing some of the research here too. And we are super fans of the DORA research because it's been a, over a decade of really high quality insights, and I've been following it the whole time in awe.
Yeah, it is. It is hard to believe, but yes, it has been over a decade. And yet, Steve, sometimes there are people that haven't heard of Dora or have maybe heard of a different Dora. So let's just level set and let everyone know that today the Dora we're talking about is a research program that, as you mentioned, has been running for over a decade now. It's been about 12 or 13 years. We've kind of lost count. But this research is looking into the capabilities that drive and enable technology driven teams and organizations to actually thrive. Our tagline is get better at getting better. We really want to help you and your team go on a journey and have a mindset of continuous improvement. That's really what Dora is all about. And the title of our talk today is Dora, Beyond the Metrics, right? We want to look beyond the metrics. But again, just to make sure that we have level set everyone, maybe we should start off with just what are we talking about when we say the Dora metrics? Well, the reality is that this research program is pretty deep and intensive and looks across a lot of different things. But one of the things that it's most known for, or most well known for, is our measures of software delivery performance. In fact, Dora for a long time has had four measures of software delivery performance. These measures help organizations and teams look at two high level characteristics of software delivery. The first is throughput. How much change are you able to move through the system? And then the second is stability. When that change makes it into production, does it land in a stable way? Now, the original four, sort of the old school metrics, are these. You have your lead time for changes, which really answers the question of how long does it take for a change to go from committed to version control. And I know the talk just before us was GitOps. So you're probably taking those code changes and putting them into Git. How long does it take for those to go from locally committed all the way through to running in production? And how frequently are you updating production? Those were the two throughput metrics. And then on the stability side, you have the change fail rate, which, Steve, I call this the O expletive rate, because this is the rate at which you push something to production and you or someone around you shouts out an expletive. Has that ever happened to you, Steve?
Uh, uh, of course not. It's never happened to me, and especially not at super inconvenient times.
Yeah, definitely not. And then finally, our fourth metric here in the classic DORA metrics is the time to restore service. So when there is an incident or an outage, some interruption to service to our customers, how long does it generally take you to recover from that? Now, taken together, these four metrics have a lot of power. First, they can be used to measure any application or service that you're looking at, whether it's a mobile application or a mainframe application or a really rich SaaS offering or even your internal platform that you're offering to developers within your organization. So I think that's a really important point about these. But then the other thing that's really interesting here, if you go back through the entire history of this research program, there are certainly those in the industry, and maybe it's a smaller number today than it was when this research began, but there are certainly those who think of throughput and stability as trade offs of one another. We can either be fast or we can have stable deployments, and you kind of get to pick between the two. But the reality is, with our research, what we've seen, again, over more than a decade, is that throughput and stability tend to move together. You're either fast and stable, or you're slow and unstable. So I sometimes like to quote Dave Farley here. He says that the choice is really, over a long enough time horizon, the choice is really, do you want better software faster, or do you want worse software slower? You get to pick. Steve, how does that what's your experience with this idea of throughput and stability being trade-offs of one another?
So I think that they are trade-offs when you set up two teams with the opposite goals. So if you have a team who are in charge of throughput and a team who are in charge of stability, that's when you will find there's conflict and it doesn't work out. And mostly it's because they end up creating lots of trip hazards for each other. So I think one of the reasons that intuitive thought these things must be in conflict doesn't turn out to be true is because in DevOps, we don't set up those teams to be in conflict. We try and give them the same shared goals. And it's almost, that might be the little simple start of a really big change.
Indeed, and that definition or that description definitely resonates with me. I spent an early part of my career sort of on that operations side. I was responsible for the production systems, and having conversations with leadership around, hey, Nathen, you've got to make these systems more stable. I know the way to make the systems more stable. Accept no changes. Sorry, you want to change something? Go away. Can't do that. Of course, that doesn't help my development peers who were trying to ship new features, and they were getting similar pressure, although maybe from a different angle, from their leadership. And at the end of the day, if we ship nothing, that doesn't really help our customers. And if we ship very infrequently, that's not helping them either. And that stability really matters. So I think this is I think part of why these metrics have really resonated with the industry. But speaking of these metrics, I've said a couple of times that these are the original 4 metrics. Our research is kind of like, well, it's kind of like your team. We don't sit still. Things are always evolving. And so over time, these metrics have evolved. We've moved the first change was that we changed from your time to restore service. We've kind of clarified the definition of that and talked about the failed deployment recovery time. And one of the reasons that we switched that is it can be really sort of difficult to take any sort of incident or interruption you have and sort of average those all together to figure out how long did it take you to recover from them. The reality is that, let's say, for example, you're deploying software in a physical data center. If a backhoe comes and cuts power to that data center, certainly happened, how long is it going to take you to recover from that? Well, the answer to that question is very different than if you ship a bad configuration, how long is it going to take you to recover from that? I hope the answers are very different. But averaging them out doesn't really give us the information that we want. We can't really learn so much from that. There are a bunch of other reasons as well, but probably the most important was that these 4 measures were always about software delivery performance. And so we really wanted to zero in or hone in, if you will, on those failed deployment recovery times. So that was kind of the first change that the metrics took. But then in the last couple of years, we've actually made one more change to them. And in fact, our 4 metrics, they've grown up. They're now 5. There are now 5 software delivery performance metrics. You'll see 4 of them look exactly the same. The 5th one, though, is the rework rate. And this is really, I think, will probably clarify some of the language around this. This is specifically the deployment rework rate. So, when you have one of those expletive moments where you have to roll something back, you're probably going to eventually ship more software. So you're going to do a deployment that is a reworked deployment, a deployment that wasn't planned. And so we really want to understand the characteristics of that deployment and how many of those relative to all of the deployments that you have come across there. So this is kind of how the 5 metrics have evolved. And Steve, I know you wrote a post just recently about these 5 metrics. Can you share a little bit of insights that you had and takeaways that you had from these?
Yeah, I think there's 2 interesting things I'd call out on this. One is that this rework rate gave me flashbacks to John Seddon's concept of failure demand, right? It's like if you imagine something simple like your job is to fold paper, and you say, I've folded 100 pieces of paper today. But if half of those pieces of paper were ones that were sent back because you folded them wrong, you haven't really delivered 100 pieces of folded paper, right? You've only delivered 50.
Right.
So that's what we're kind of talking about here, is that maybe you've got quite a good looking deployment frequency, but if half of your deployments are to deal with these kind of failures, that's an interesting number, and that's something to kind of look at. The other thing that I think is really interesting, and I think you could probably give us some insight into this, is that the throughput and stability has changed here, right? Because one of our metrics has popped across from the stability camp into the throughput camp.
Yeah, that is really interesting. So the failed deployment recovery time, good eye there, Steve. That has moved from a stability metric to a throughput metric. And I will share some of the rationale behind that. When you have a deployment that goes off, it fails, something's gone wrong about it, and you need to immediately intervene. You kind of have, I would say, at least at a high level, kind of two choices. You can either roll back that change, or you can push forward some new software. And even if you roll that change back, you're probably going to end up pushing forward some new software. So this failed deployment recovery rate then, or recovery time, sorry, is really a measure of software delivery performance, because to fix that failed deployment, you're shipping more software. Now, the interesting thing about this, and the way that I kind of like to think about these, is your lead time for changes. That's kind of your normal lead time for changes. I've got a new change, I need to ship it off. Let's get that out into the hands of our customers. But when it goes wrong, now we have kind of an incident or an emergency. Maybe we have an emergency fix that we need to deploy. That would be the failed deployment recovery time. It's a measure of throughput, right? We're still pushing software through. But when you compare and contrast your lead time for changes and your failed deployment recovery time, you'll probably find, hopefully, that your failed deployment recovery time is either equal to your lead time for changes or maybe even a little bit faster. And so at a conceptual level, you're kind of measuring the normal changes and those emergency changes. That's the difference between the two.
Yeah, I love that. And one of the interesting thought exercises around this is if you're able to ship a fix quite quickly, the idea should be how can we just ship all of our changes in a similar way, right? So it's kind of that's one of the thoughts behind continuous delivery. It's like we've proven that we can do this really quickly when we need to. So why does it take us like 2 months when it's not an emergency?
Yeah, and one of the key insights that most teams end up having around that exact question is, well, when it's an emergency, we're just shipping a little bit. We're not shipping a lot. We're just shipping a small bit at a time. Yes, mind blown, right? That right there is the key insight. If we ship in smaller increments, it is very easy for us to increase both the throughput and stability of those changes. And in fact, if we're shipping something small and something goes wrong, first, it's easier to repair or to roll back. But second, because it's small, maybe we've actually contained the blast radius of that incident and it's not impacting all of our users necessarily. So when you start thinking about just ways that you might improve both throughput and stability, you start finding lots of little things that you can do, like shipping in smaller batches, like focusing on how deployments get released out to your customers. Maybe you're doing something like progressive deploy, where you start by releasing to a small number of users, maybe catch an issue there before it hits all of your users, and things along those lines. Yeah. So that's super cool. And those are the software delivery performance metrics. But we said we wanted to look beyond the software delivery metrics. So let's go over to Dora.dev. Now, Dora.dev is where the research program publishes all of our findings, has information and insights into the metrics and so forth. And I really like to start right here on the research page itself, because the first thing that we come across on the research page is this DORA core model. This model represents sort of all of the findings that we've had over the decade plus. We kind of consolidate them down into one model to help you better navigate how things work. And you'll see right here in the center are those software delivery performance metrics. But as this is more than or beyond those four metrics, you'll see immediately that there's also reliability metrics, things like operational performance. We do consider that separate from software delivery performance, but they certainly are related and inform one another.
And it's kind of crucial here because I think a lot of people have heard of the four keys, the five keys as they are now. Um,
Yes.
but even in terms of measurements, there are more ideas to be found in this model about things that you might want to measure. And reliability is a great one. There's also these cool things over here like job satisfaction and productivity and
Yes.
reduced burnout. These sound like good things to have in an organization too.
Well, burnout maybe not so much, but yes, the reduction in burnout, absolutely a good thing. And this is another key point about these metrics. I like to say that these metrics sort of form the center of gravity, if you will, for DORA. What our research has shown is over the years, these metrics are predictive or are leading indicators for those outcomes that you care about on the right. Things like organizational performance and well-being, but they are also trailing indicators for the capabilities and conditions that you see on the left: a climate for learning, fast flow, and fast feedback. The reality is that you don't improve software delivery performance by thinking really hard about your deployment frequency or by mashing the deploy button. Well, I mean, I guess if you mash the deploy button over and over again, that will improve your software delivery performance, but not in a meaningful to the business way, right? And so this is really interesting. Those performance metrics, those software delivery performance metrics in particular, they help us predict what the outcomes are going to be, and they provide a trailing measure for how are our capabilities and conditions, what's our engineering excellence, if you will, look like in our engineering practices. Now, we can go much deeper than just those top level categories. In fact, I'm just going to expand it out here. Ooh, that was fun. Did you see that navigation or that animation there, Steve? Watch this. Ooh.
I love that.
Isn't that fun? Yeah. I mean, I could just do that all day, but of course we wouldn't be improving much if we just watched the web animations happening. But so what stands out to you here, Steve?
So for me, this is really the crucial thing. The metrics are the useful signal and the thing that we can use to inspire us to find ways of improving. But for me, the real like calories in this model are the things in this dark blue box on the left-hand side, which are these concrete things that we can do. They're called capabilities, which sounds really cool, but it's stuff we can do that will help us to deliver software better. So these are the levers we're going to pull to solve the problems that we have and that are making us work in larger batches and have problems.
Yeah, I love that sort of metaphor as these are levers that we can pull. And frankly, some of them as a team or as an individual, you might have access to, and others you might not. I tend to think about these capabilities also in the idea of levers and knobs and dials and so forth as kind of like you're sitting in a cockpit. And maybe it's a cockpit for a very large airplane. And so there's a pilot and there's a co-pilot, maybe there's even a navigator. Well, if there's a navigator, the navigator has access to some knobs and dials that the pilot cannot reach just because of where they physically sit. And I think that's true about these capabilities as well. I mean, one of the capabilities that you'll see here is a generative culture. And this is a culture where information is shared, where risks are encouraged, where when something fails, we try to learn from that. Now, you can't just walk into a new job or walk onto a new team and expect that, well, within the next quarter, I'm going to significantly change the culture of this entire organization. You can't reach that lever. I mean, you can start to influence it, but you're not going to be able to fully reach that lever, if you will. But then we have other things like version control. Maybe as an individual contributor, you can start making sure that every artifact that we have is stored in version control. So some of these levers you have access to, and some of them maybe are a little bit more distal. And that also might talk about the time horizon over which you can change them.
That's right. And I think one of the things to bear in mind is that some of the small things that you do control will actually help you to bring about the things that are maybe even outside of your influence. So the example I often use is I've been on teams where we've done such a bad deployment that nobody trusted us.
Mhm.
So we needed to do things like add monitoring and observability and do deployment automation to show that we were actually trustworthy, which then allowed people to give us more autonomy to make other changes that maybe were outside of our control, such as reducing the overhead of change approvals.
Oh, yeah, absolutely. And I love that idea that, we can make a small local change, and that's going to have a ripple impact or a ripple effect and drive the larger changes that we need to have. And that whole idea of trust, I can't tell you how many times I've lived that when it comes, especially when it comes to deployments. When we had in a previous role, when we had a lot of failed deployments, and we went to the business and we said the best way to fix this is to ship more frequently. As you can imagine, they weren't super excited about hearing us say that we were going to break things more frequently, which of course wasn't what we were saying, but it is what they heard because that was their lived experience. Now, the other thing that I really like about how you approach this is, with those capabilities on the left-hand side, that it kind of gives you an idea of these are the practices, the conditions, the capabilities that we need to have on our team in order to drive better software delivery performance. So that's really good, but there's already a lot of capabilities there. So where do I get started, Steve?
Well, I think probably by trying to work out the current state that you're in.
Mm. Yes, I think that's a really great idea, and I've done this a couple of different ways. I'll describe one, and then we'll walk through one of them. One way that I've done this with teams is, frankly, we take this model and we print it out on a giant poster-sized board, and I give teams red and green stickies, and maybe some yellow stickies, and maybe you get two or three of each, and I say, okay, look at this list. Go put the red stickies on the things that you experience that are bad or have lots of opportunity for improvement. Put the green on the ones that you think are good, and the yellow on those that are maybe in the middle or you're curious about. And it is fascinating to watch as a team comes together and starts doing that on this map or on this model, how clusters start to emerge. We think we're really good at version control. We think we have lots of opportunities around documentation quality. So that's really one way that I find is super successful to help teams, because then it also helps them understand that, well, we're pretty weak in documentation quality, but we're pretty good in version control. Let's make sure we're the best at version control. What happens when you do that, Steve?
Well, I think one thing I'd quickly add there is that having the team in the same room doing this, or like all together doing this, and making sure it is that whole team. The cool thing about that is someone will be new to your team, and they will see the gaps in your documentation which you don't see. It happens every time. Whenever someone new comes in, you're like, our documentation is great. You'll have no problems. And it just immediately they'll say, where's the version control? Like, where do I go to find my repository? And it just won't even be in there because it's so obvious to you. But yeah, once you can actually map out and highlight these hotspots, for me, it's like being curious about finding out how to actually implement this new skill that you have to try and acquire.
Yeah, I love that. And that leads me right to a way that I want to show you that you can actually kind of do that together with your team right from the Dora.dev website. So I'm just going to pop over here to the quick check. And the quick check starts off by helping you sort of assess how is your software delivery performance going. And what you'll see here is that well, our deployment frequency could probably improve. We are still only showing you or measuring 4 of the 5 metrics here in the quick check, but stay tuned. It's a website. Things are always changing. So I've not really considered the answers. I've just thrown in a bunch of different ones. What this does immediately is it helps me get a baseline for my team and understand how is my software delivery performance going today. Now, one of the things that I did that was terrible just now is I just answered those questions myself. To your point, Steve, it's really much better if we can bring together sort of a cross-functional representation of the team that is required to build and deploy and operate this application and talk through those answers, because we all may have slightly different lived experiences with each one of those. But then now we know how we're doing. We want to start prioritizing some of those capabilities or even assessing some of those capabilities. The quick check actually helps you with a couple of them. And I think this is really important because one of the things that we can't do is just say, are you practicing continuous integration? Yes or no, or like on a scale of 1 to 10, how are you doing with continuous integration? The challenge with doing that is how I think about continuous integration might be different to how you think about continuous integration. So what we do here on in the quick check is we actually give you some characteristics, some pointers or some signals around how good are you at continuous integration. For example, Steve, where you work, do code commits result in an automated build of the software? How
Yes, they do.
strongly do you agree or disagree with that?
Yeah, they definitely do. We have
They definitely
automated
do.
builds.
Awesome, awesome. All right, I'm first. I'm going to ignore your answer, and second, we're not going to go through all of the other questions because we just simply don't have time to. But you can imagine, maybe my experience is different to yours, Steve, and so just talking through that, we can already start to get some good understanding of maybe opportunities for us to improve. We can do the same thing here with loosely coupled teams. And then finally, with your generative organizational cultures, information actively sought. Again, I'm just going to throw in a bunch of random answers here. New ideas are welcomed. I strongly agree with that. And now we can view the results. And so, what this does is it shows us sort of that stack rank of which capabilities are we really strong in and where do we have the most opportunity to improve. So, Steve, what would you like to do next here?
Well, I think we need to find out a bit more about continuous integration so that we can work out how to
Yeah,
strengthen our score here.
I dig that. Let's do that. And so, right here on Dora.dev, again, we've got guidance on every one of those capabilities. And the articles around those capabilities follow a pretty similar pattern. First, what is that thing? In this case, continuous integration. How do you go about implementing it? Some of my favorite parts here are the objections and the common pitfalls that you might run into. Because, we're talking about changing things. Change is hard. Change is hard. It's hard for a lot of reasons, and sometimes people are resistant to change. They're well into their workflows and very happy with them and so forth. So it's always good to think about those. But then we also have, sort of rounding out the article, ways to measure each one of those capabilities. So again, there's certainly more than 4 measures within DORA. There are hundreds of metrics, hundreds of measures that we look at. So this gives us a way to get a good assessment of how we're doing with continuous integration today. And then, of course, some what's next, because there is no such thing as a good article without something that tells you what's coming next. But in any case, now that we've got an idea, we could actually, I don't know, maybe set some OKRs around these factors. But more importantly, what we can do is we can sit down and we can write a hypothesis, Steve. We can say that our goal is to improve our software delivery performance metrics. We believe that by improving continuous integration, we're going to see an improvement in those software delivery metrics. And as those software delivery metrics improve, we also expect to see better organizational performance, whether that's commercial performance or non-commercial performance, like customer satisfaction or something like that. And we expect to see better well-being for the people on our team. So we've just set up a nice hypothesis that we can now go and test as a team. Talk about a great way to learn and experiment as you go.
And with this hypothesis, right, we test it for a week and then we realize it's not working, so we give up, right? Or is there a J curve here?
Yeah, so the J curve is really, really interesting. I'm glad you brought that up. First, something like continuous integration might take you a little bit more than a week to get well practiced in and sort of build the habits of practicing continuous integration. There might be technical challenges, and there certainly might be process and people challenges or changes that need to go into that. But with all change, we have seen over and over again in our research what you just called out there, the J curve of change, where maybe there's a little bit of low hanging fruit and we pick all of that really good and we're really excited about how this change is going. But as soon as you've picked all of that low hanging fruit, the change gets hard. It gets difficult. Maybe you're having problems scaling that change beyond one team or across your organization. Maybe you've run into some technical roadblocks with it. Who knows what? But that's where your productivity might actually take a dip. We have to recognize that that's likely to happen. And we've seen that happen again and again with a number of things across the research. But what happens on the other side of that is the J bottoms out and we come back up and we eventually get to a place where we do have better performance. So it is really about building that practice of experimentation and learning. And you have to stick with it so that you can really recognize and realize the gains from those new capabilities that you're building.
That makes total sense. It's like having a savings account and putting money in it, and then in the next week saying, "Well, the number hasn't gone up." It's
Yeah.
like I'm not getting any interest. It's like, well, the interest comes over time, and it kind of compounds and gets bigger and bigger. So you kind of have to invest for a bit of time. It's not decades. It's shorter than that, but it's definitely longer than a week.
Absolutely, absolutely. And you might start to see some changes within the week, but it is this is why we have that tagline of get better at getting better. It's a process of continuous improvement, and it's those iterations and that iterative approach where you're learning as you go and building those new habits. One of the challenges, though, I find with that is because you are making relatively small steps forward all the time, we tend to stop and look back at just how far we've come. You get 6 months, a year into this journey, and it feels like you've only taken a few small steps. But if you stop and reflect and really look back on some of the changes that you've implemented over that year, I think you'll be blown away.
Yeah. And that's one of the reasons why it can be useful to measure, because that way you can then see that difference, in a way that we often forget, like the pain of the past. That's why I've got so many tattoos. But if you actually can look back at a chart and see the difference, it can remind you of how big a improvement you've made.
Yeah, absolutely, absolutely. Now, Steve, earlier you mentioned that you were an Octonaut, yes, but something else that you said there at the beginning when you introduced yourself. What was that?
About being a Dora community guide.
Yes, yes, the DORA community guide. What exactly is a DORA community guide?
So that's a very good question. The Dora community is a group of people who are all interested in this subject. It's the topic of how we measure software delivery, but also the things we do to actually make a difference to how well we deliver software. And there's a whole community of really cool people. And every time I turn up to one of these, I learn loads. As a Dora community guide, I'm here to help kind of grease the wheels on it and get conversations going and kind of like cheerlead the research when it comes out. It's one of my favorite jobs. So look out for me doing that. So yeah, come and join the community because we have conversations on a regular basis and they get super deep and super interesting. I always say like we kind of go there and we talk about things like these metrics because we're the cool kids and anyone who agrees that we're the cool kids, this is definitely the place to be.
Yeah, absolutely, absolutely. And you can get to that community right here from the community link on Dora.dev, which takes you to Dora.community. And from there, you can join the community of practice. That's a mailing list. We get together regularly and have online discussions where, as Steve mentioned, we're talking about what we're learning with taking these findings from Dora and putting them into practice. Now, Steve, you also mentioned that you're there and you're oftentimes sort of championing the latest research. Well, Dora, if we haven't mentioned it, puts out some research papers regularly. Each year we have an annual report, and our 2025 annual report came out back in September. And this year's report is the state of AI assisted software development. Now, I want to thank Octopus Deploy for being one of the sponsors of this year's research and the report. So thank you for your contributions there. That's super good. But this report, as it says on the title there, really digs into the state of AI assisted software development. Steve, do you have any like top takeaways or insights that you had from reading this report?
Yeah, I thought it was really interesting. There was relationships in there between things like platform engineering and AI.
Mm,
There was also a chapter that I really enjoyed on value stream management, which is super important when you're making improvements because if you haven't heard of theory of constraints or these kind of processes, if you kind of optimize the wrong part of your process, it either doesn't make a difference or it can make things worse. So that was super interesting. But there's also a very cool model in here that shows you what you need to have in place if you want to be successful using all of these cool new tools.
absolutely, absolutely. So let me recap some of those things and share some again, just some more resources over here on the Dora.dev website. I'm going to go up to the guides section. And you mentioned value stream mapping and value stream management. We do have a whole guide on exactly how you and your team can put value stream mapping into practice. And it goes into a lot of detail, provides a lot of good insights into how to do this. And you may end up with something probably not quite as linear as this, but you'll end up with a good understanding of what does your software delivery process look like. To your point, Steve, we can find some bottlenecks. One of the things that we found in the 2025 report is we looked at how teams are incorporating AI is that AI is really sort of a mirror and an amplifier. And that amplification effect of AI, Steve, I think you probably gave me the best metaphor to talk about that. And it has to do with amplification. I hope you remember what it is.
I do, and I
Okay.
remember this because I obviously enjoy listening to bands, and I go and see a band that I enjoy, and they amplify them, and it's great because we can all hear them. But I also used to be in a band where I used to sing, and when I got amplified, things weren't quite as good. So it doesn't matter necessarily that this thing can make you a lot louder. You kind of have to do the right thing first before you then amplify it. So I should have learned to sing.
Yeah, there you go. There you go. Learn to sing. But this is one of the things that we've seen, with lots of teams using more AI to generate more code. Oftentimes, the time it takes you to generate code or the amount of code that you have is not the bottleneck in your system. So if you're generating maybe 2x, 5x, 10x the amount of code, and it has to go through that same approval bottleneck, you're probably not making things better. In fact, you might be making things worse. So we have to be careful about that. And this is one of the powers of value stream mapping. It helps us visualize our entire system and identify some of those constraints. Now, the other thing that you mentioned there, though, is a model. So I'm just going to pop over here to the AI tab because it's 2025. Everyone's talking about AI. Actually, just this morning, talk about timely. This report is hot off the presses. We've just released today the AI capabilities model report. Now, the capabilities model is something that we introduced in the 2025 report, that state of AI assisted software development. And the reason we introduced it was because what we were seeing was nearly universal adoption of AI in our sample set, in the people that we were researching. But we were seeing huge variance in the types of performance that people were seeing. And that led us to this understanding that it's not AI that's driving all of the performance. In fact, it's not if you're using AI, because nearly everyone is, but there's maybe something to how you're using AI. And so we wanted to explore that, and our research to help us do just that. And it led to this AI capabilities model. And the way that this works is kind of similar to that core model that we looked at before. In fact, I would say that this is a nice complement to that core model that we looked at before. On the left-hand side of this model, we have AI adoption, which everyone is doing. You're probably doing it right now. How do we get more AI on this team? On the right-hand side of this model, though, we have some of those outcomes that you really care about, things like team performance, code quality, individual effectiveness, and so forth. And in the middle, we have these capabilities. And essentially, what we're saying here is that when you have AI adoption coupled together, in this case, with strong version control practices, those strong version control practices will amplify the effect of that AI adoption on both team performance and individual effectiveness. So this model becomes now something that you can explore together. So if you wanted to, as an example, improve product performance for your team, you can come over here, just highlight the product performance outcome and see that with AI adoption is going to have the strongest impact on product performance with access to internal data, with working in small batches. Hey, it's coming back, and a clear and communicated stance. Now, you can then dig into what each one of these means. Click on the capability. You can go ahead and learn more about that. And again, you'll find over here a capabilities article that talks about exactly what that capability is, how you can put it in practice. Again, some of those pitfalls, why it deserves investment right now, maybe how to measure it, and so forth. So this is what we think is a really powerful way. And like I said, this model, this report just came out today. So honestly, shipped is Well, it's the place where we're shipping this report. So thank you so much for having us because I'm really excited to help teams understand how best to get the most out of AI.